6.5. Because we will be talking about 6.5. And then after that, 6.6, the inverse, the trigonometric inverse function. All right, so let's take a look at your 6.5 here. So 6.5, we talk about, let me share the screen. 6.5, we talk about the tangent, the cotangent, the secant, and the cosecant graph. I just want to point out to you guys again that in your finals, you won't have a multiple choice like this. You won't get like, what is, no. You have to draw this all on your own. Do you guys know how to draw like a tangent or cotangent graph? Brian, Parker, or any? Do you need help with drawing this?
Sorry, my mic was muted. No, I remember it pretty decently, so it should be okay.
We talked about it last week, didn't we, a little bit?
Yes, we did.
Okay, then I think I should be good then.
The tangent and the cotangent and the secant or cosecant graph, when you graph it in the test, you do need to draw me the asymptotes. Okay, you need to draw me the vertical asymptotes, and you also need to draw me the horizontal asymptote. This one doesn't draw. So when you guys draw the tangent, secant, cosecant, cotangent graph, you have to draw me the asymptotes, both vertical and sometimes horizontal, depends on the secant, cosecant has horizontal ones. Andre, you got questions for me on this section 6.5? Andre, you just came in.
No,
Okay, you are having echo there, so cannot hear you just now.
I think he said he's okay.
You say it's okay? Okay.
I think so.
I cannot hear him. It's echoing there. Can you say that again, Andre? I'll type it out because I cannot really hear it just now.
I said I'm good.
Okay, you're good. All right. So one thing I want to see again, make sure you guys know how to asymptotes are very important, especially when you in a test. So make sure you guys know how to draw this. But I'm concentrating on this kind of questions now, like 25 and 26 or 27. So just want to point out to you guys that these kind of questions are very important. And this is because we are doing the inverse coming up next year. So in order for us to do this, the first thing you need to know here is the special, the exact value. So back in 6.2, we talk about the trig exact value. Let me see. I know it's here somewhere. There you go. We did talk about the trig exact value. This one. So this trig exact value will be used for this kind of 25, 26, and 27. So for example, here is it says that the solution has to be negative 2 pi to 2 pi. Tangent x is √3. So when you look at tangent, which is this one, and you got √3, which is this one. So your answer in this case will be pi over 3 or 60 degrees. So this answer is going to be pi over 3. But as you know that is inside this domain, negative 2 pi to 2 pi. But I want to point out to you guys that this have 4 answers, and one of them is pi over 3. So do you guys know how to figure out the rest of this? Okay, so we know that pi over 3, which is 60 degrees, the tangent will give us square root of 3. So this is one of your answer. But as I told you, you should have 4 answers here. The reason why is because they give us the negative 2 pi to 2 pi. So does anyone here know how to figure this out? This is something that I will ask also in the lecture. Anyone? So you got one answer here.
You just add and subtract pi over 3?
No. Good try, but no. Okay, so I want to point out to you guys that again, we're gonna use the all students take calculus here. Okay, and since this is a positive, so what quadrant is positive for tangent? quadrant 1, and quadrant 3. So the pi over 3, which is 60 degrees, is over here. So can you find out what is that in quadrant 3? You guys know how to do that? This is still going to be pi over 3 because it's going to be the same. So anyone know what is that going to be? Pi over 3 in quadrant 3.
Would that be 240 degrees?
Which is in radian.
Yeah. 4 pi over 3?
4 pi over 3, yes. Now this only happens from 0 to 2 pi. So that's why you only get 2 answers. So the other 2 answers is from negative 2 pi to 0, the negative part. So how do you figure out the negative part over here? So if this is 60, how do you figure out the negative of this? Then you have to go clockwise, right? And how do you figure this angle going clockwise? Is you subtract 360. Or another meaning, if it's in radian, we subtract 2 pi. So my question is, what happens when you have pi over 3 when you subtract 2 pi? What do you get? It's going to be negative. Anyone? This is definitely over 3 for sure. This is definitely coming up in your test. You're in your finals. So I'm pointing out to you.
Is that going to be, is that 5 pi over 3?
Negative 5 pi over 3. And same thing happens to this one, the 4 pi over 3 that you get in quadrant 3. So in order for us to get the negative part, again, what we do here is we subtract 2 pi. So what you get when you take 4 pi over 3 when you subtract 2 pi is also a negative. Total must be 6. Total is 6. So 4 plus what is 6?
2. So
yep.
Is that negative 2 pi over 3?
So your answer in this case will be 5 pi over 3, 4 pi over 3, negative pi, 5 pi over 3, and negative 2 pi. Is that tough? And this is how we do question number 25. Now you guys do question 27. Cosecant x equals to 2 root 3 over 3. So look at here and see which one of these give us cosecant. What value of cosecant give us 2 root 3 over 3? Cosecant, not secant. Ryan, Parker, Andre. The other girl just laughed. She's just scared.
Pi over 6.
No, pi over 6 is not cos. It must be cosecant.
Pi over 3.
It's still pi over 3. Yep, because it's this one. All right, so we know that this is still going to be x in this case is still going to be pi over 3, which is in quadrant 1. Can someone tell me cosecant is positive in quadrant 1 and also quadrant 1? All
Is
students.
that quadrant 4?
C stands for what?
Quadrant
Oh,
2.
sorry. Yeah. Cosecant would be quadrant 2.
Which is the same as secant, right?
Yeah.
Yep. So what is pi over 360 degrees in quadrant 2 now? So over 3, this is not that tough. This is 1. Quadrant 2 will be
Is this just 2 pi over 3?
And then what do we did with the negative part? We subtract this by what? 2 pi, right? So what you get for this one when you subtract 2 pi, which is the same thing, 5 negative 5 pi over 3. And what else?
4 pi over 3.
For negative, forget the negative. Yep. Tough? You guys just need to practice. And what we are doing here is called the inverse function. So if I want you to figure out tangent x is square root of 3, square of 3. So when you move the tangent over, what you have is the arctangent or the inverse tangent of square root of 3. So if you take out your calculator has an inverse tangent, which is this one. So if you take a square root of inverse tangent of square root of 3, square root of 3 is this one, and then you do the inverse tangent of it, you get 60 degrees. So your calculator only give you the quadrant 1 answer, but you have to figure out the rest of it on your own. You with me here?
Yes.
Okay. How about if same thing happens here when you do this, you move your cosecant over. So this is actually the inverse cosecant of 2 root 3 over 3. But if you look at your calculator, you don't have a cosecant, right? You only have tangent, sine, and the cosine and the inverse, right? So this is about 6.6 now. So my question is, how do you figure this one out using your calculator? Is because we don't have a cosecant. So, and cosecant is the reciprocal of what?
Sine.
Sine. So you can do this. You can change this to the inverse of sine, which is what you do here is you flip-flop him. So become 3 over 2. So in order for you to do the cotangent, the cosecant, and the secant of the inverse, because your calculator doesn't have that. So in order for you to do this is you change it, but then you flip-flop the inside one. So what you do here is for this question, you figure out what is 3 over 2 root 3. This is a bit hard. If I rationalize this is actually root 3 over 2. If I rationalize this. So the arcsine of root 3 over 2, let me clean this one up. So if you have root 3 over 2, and then you find the arcsine of this, it's got 30 degrees. Huh. Let me see. Is this root 3 over 2? Oops. No. Yeah. Sorry, this is root 3 over 2. But it's the arcsine. 30? Let me just do it again. Should be 60, right? Should be 60. Sine, cosecant, yep. Let me do it again, sorry. So clear the whole thing up. Root 3 over 2, which is this one, 0.86, and the arc sine of it. Yeah, 60, there you go. That's it. What's going on? So yeah, so this is how we do this kind of questions here. So make sure you, so this is for when you do your 6.6 homework. So when you do the 6.6 homework, when the question is asking you to do the arctangent using a calculator, like this one, this is easy because your calculator have arc sine and arc cosine and arctangent. But once you hit the secant, cosecant, cotangent, then you have to flip it around. You guys okay with this one?
I think it should be good.
It's mostly the next thing about your the real part about your arc 6.6. This is what we talk about 6.6 round when we do the inverse function, is talking about the definitions of inverse function. So this is what it means by inverse sine. So if you look at sine function, the sine function is a valley, is a hill and a valley. So in order for us to have an inverse function, the inverse function has to be one-on-one. One-on-one means that it will pass the vertical, the horizontal line test, sorry. It will pass the horizontal line test, but unfortunately, if you draw the horizontal line test, it fails. So if you fail the horizontal line test, it doesn't have a one-on-one function. However, if you restrict the domain, it will be one-on-one. So what they do here is they restrict this domain, this little green line. So what do you mean by restrict means that they will erase all this. They don't want to do that. They don't want to need this. And they restrict on here. And when you restrict on here, when you do the horizontal line test, they pass because you only cross at one point. So then it has a one-to-one function. So what I want to point out to you guys here is the sine x has the inverse function, which is called the arc sine of x, or sine minus 1 of x, as long as you restrict the domain. So your domain here, if you look at the whole sine function that I draw, this is going to be pi over 2. And this will be negative pi over 2. So if you restrict the domain of this from negative pi over 2 to pi over 2, and your range is from negative 1 to 1, draw bracket, which is, this is negative 1 and this is 1, then it has its inverse function. And the inverse function, the domain and range is being flipped. That means that your domain here will be negative 1, 1. And your range here will be negative pi over 2 and pi over 2. So this is very important when you talk about this is a basic of the inverse function for trigonometric function. Same thing happens to cosine. So if you look at cosine, cosine graph is the valley. And again, it does not pass the horizontal line test. So what do? I restrict the domain. So I take this and I just restrict it to just part of it. So I erase the rest of it. And when you erase this, and when you restrict the domain, then you find out that this has an inverse function because it passed the horizontal line test. So what happens here is it will, if you restrict it, it will have an inverse function, which is the arc cosine of x. So again, the domain for this restriction is going to go from 0 to pi because it will stand at here, including. And the range is going to go from negative 1 to 1 because it goes from -1 to 1 here. So when you do the inverse function for cosine, the domain here is going to be -1 and 1. And the range here is going to be from 0 to pi. And if you look at the quadrant, it's very strange. It's because if you look at the sine function, the -pi/2 to 0, this is actually in quadrant 4. And then 0 to pi/2 is quadrant 1. So when you look at the sine function, they only do quadrant 4 and quadrant 1. And they don't do quadrant 2 and quadrant 3. Same thing happens in cosine. If you look at cosine, they only do quadrant 1 and quadrant 2. So this is Q1 and this is Q2. So they don't use quadrant 3 and quadrant 4. And then we're going to talk about tangent. Tangent, the graph of tangent is going to be the cubic graph. And it has a domain from -pi/2 to pi/2. And then you have another cubic graph like that. And it goes from 3 pi/2. And then it has another cubic graph. And if you do all this cubic graph, it will not pass the horizontal line test because every horizontal line, you got 2 or multiples. So what do I do is I have to restrict the domain. And that domain is from, again, we only take one of these tangent graph. We do not need to have this, the other repeat ones. And if you just have this tangent graph, then this tangent graph will have its inverse. And its inverse in this case will be the inverse of tangent, or we call it the arctan. And if you look at the domain and range, the domain for tangent in this case is going to be pi/2 to -pi/2 to +pi/2. But this is in parentheses. And if you look at this, this is all in brackets. So I just want to point out to you that the sine and cosine, they're all in bracket. The tangent is parentheses. It's because they are asymptotes. This graph cannot touch it. So that's why you have to use parentheses. Your range here, since it goes from negative to positive infinity, is going to be all real numbers. So when you have its inverse, your range in this case, your domain in this case is going to be all real numbers, which is a flip-flop of this. And your range in this case will be from -pi/2 to pi/2. So this is the basic of tangent, cotangent, tangent, sine, and cosine for the inverse function. And why this is so important to us is because of the domain restriction, and you have to figure out what is going on here. So for example is, if you have what we call as a composition of 2 functions, for example is if you have sine of sine, the inverse of sine of 1/2. If they are exactly the opposite, like exactly the same trait, but they are inverse each other, they will cancel out. Your answer in this case will be 1/2. However, if you have a 3/2, and yes, these 2 will cancel out, your answer here will be undefined. So can someone tell me why this answer is undefined? This is very important. This is in your test. It's going to be coming out in your test. This is anyone? So this will get 1/2. Why this is not 3/2? Anyone? The reason why is because
there is no 3/2 in the sine. Is there no 3/2 in the sine?
the reason why is because 3/2 is not inside this domain. See, your domain is only go from -1 to 1 because your sine graph only go from -1 to 1, and 3/2 is 1.5, right? 1.5 is here. The graph will never cross 1.5. So that's the reason why your answer is undefined. Same thing happens to your cosine. If I give you what is cosine of a inverse cosine of, let's say -0.8, then what will be your answer in this case? These two will cancel out, so your answer is -0.8. Is the domain matched? Is it inside your domain here, -0.8?
Yes.
So that is your answer. But what happens if I change this to square root of 2? So they will cancel. Is your answer square root of 2? Does anyone know what's is
no.
square root of 2 inside this domain?
No, because it's like close to like 1.4, isn't it?
Yep, you're correct. And that's why this answer is undefined. Tangent is good news. Why I say tangent is good news? Because tangent, the domain is what? The arctangent, the domain is all real numbers. That means this, all real numbers means any number works. So this is still going to give me square root of 2. You okay with that?
Yep.
Yep.
So this is when they are the same, right? And this is sine, and then this is the inverse sine. Now I'm going to switch them around.
So you use the domain of the inverse if it's in the parentheses?
Yes. Now I'm going to switch them around. So this is switch around. So again, these two will cancel. But if you have, if you switch that around, you don't look at the domain anymore. You look at the range. Is pi over 4 inside this range? Yes, pi over 4 is inside. You see what I'm trying to say? So you have to be careful, really carefully here. Depends on what we have, sine or sine minus inverse first. So you sine inverse first, you look at the range. Otherwise, look at the domain. What happens if I change this to become uh, 5 pi over 3? This is 5 pi over 3. So these two will cancel as usual, and this will be 5 pi over 3, right? So my question is 5 pi over 3 inside this range?
No.
No. So a lot of students think that this is going to be like what we just did here. Oh, it's not inside this range. It's undefined. This is wrong. So for this is special. So can someone draw where is 5 pi over 3 in the unit, in the circle here? What quadrant is 5 pi over 3 belongs to? It belongs to quadrant 4. So negative pi over, so this is the whole thing here, is 5 pi over 3, right? So can someone tell me what is the one that is going negative? Because we need the negative. This is -1. We did this just now. The total has to be 6, right? 6 pi over 3.
Negative pi over 3.
So this will be negative pi. And is negative pi over 3 inside this range?
Yes.
Yes. So that's why when you have this case, if you find out that your answer is not in the range, you have to fit it right into the range that we given. So there is no such thing as undefined in this case. For this, yes, you can have the cases of undefined, but for this case, no. Same thing happens to cosine. I'm going to do a few more for this. So cosine, the inverse cosine of cosine, again, we do 5 pi over 3. So again, these two will cancel out. So you get 5 pi over 3, right? Which is the same thing as this, the same picture that you draw. So a lot of students think that your answer is negative pi over 3, which is the same as what you just did in here. This is wrong. Does anyone know why that is wrong? See, this is all difficult. Anyone know why that is wrong?
Cosine's only quadrant 1 and 2.
We are correct. You are correct. The cosine is only go from quadrant 1 and 2. Negative pi over 3 is quadrant 4. But quadrant 4, this is quadrant 4, right? But you know that quadrant 4 cosine is positive or negative? Quadrant 4, the cosine is, remember, all students take calculus.
It's positive.
It's positive. So in this case, why your answer is negative, then your answer should be just what?
Pi over 3.
Pi. So you have to be careful with this kind of question. That's why I'm pointing out to you here. When you have the same, they can cancel out. Depends on which one comes first. If sine comes first, you can have an undefined case. It's looking at your domain. But if you have an arc sine or arc cosine come first, then your answer is going to be in degree angle. So this is a value. This is an angle. And your angle has to match with the range and with this quadrant, this given quadrant. So that's why it's very, very difficult. Some students have struggled with this. They do not know what to do because they doesn't know which quadrant is the right quadrant. And a lot of students say undefined here, which is wrong. And a lot of students give negative pi over 3 here is also wrong because it has to be back in quadrant 1, pi over 3. You guys okay here with this? Now,
Yep.
this is for when they match sine and sine, cos and arc cos and stuff, something else like that. So when you do your homework, if they have a match like tan and arc tan and cos and arc cos, then you can use that way. But what happens if they do not match? Means one is cosine and one is arc sine, one is cosecant, one is arc tangent. So how are you going to do if they do not match the same thing? So it means one is like what we have over here. Do you know how to do it?
What was it again?
This is all coming up in your finals. That's why I'm going to be so, and this is very important, especially when you're doing calculus. So if they are different, like cos and arc sine and cosecant and arc tangent, something like that, then you have to draw a right triangle. Okay, so I'm going to show it to you what happens like question 26. So when you have a cosine of arc sine, which is arc sine minus 1 of 15 over 17. So what you need to do here is you have to set this to become theta. So theta in this case is the arc sine of 15 over 17. And then we can always move this arc sine back to here. It's like an equation, add, you subtract, multiply, we divide. So when you move this, the arc sine will become just sine. So with this, we can draw a right triangle. And how do you draw a right triangle depends on the quadrant. So it looks like a ribbon. Again, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. So sine is positive. So sine is positive means it has to be in quadrant 1. So the triangle that you draw looks something like this. And we have to use your SOHCAHTOA. So sine is what over what?
Opposite over hypotenuse.
So that means that your opposite is going to be 15. Your hypotenuse is going to be 17. You have to find your adjacent using your Pythagorean theorem. So 15 squared plus b squared equals to 17 squared. So 15 squared is 225. 17 squared. Anyone got a calculator?
B squared would be 64.
I'm sorry.
B squared would be 64, so B would be 8, I believe.
8. Okay. Yep, 289. Take away 225. Yep, so B in this case will be 8. So this is 8. So now what you do here is, this is doing cosine, because this whole thing is replaced by theta, and this is theta. And what is cosine theta using SOHCAHTOA? What over what?
Adjacent over hypotenuse.
And what is adjacent and hypotenuse in this case?
8 over 17.
So your answer in this case is 8 over 17. So this is 8 over 17. So this is what happens if you have a different, if you have a cosine and the arcsine that are different, then you have to draw a right triangle and do that. You guys all right here?
Yeah.
Yep.
Tough?
A little bit.
Okay, I want you to try 28. Secant of arc cosine of negative 5 over 6. And again, you always let this become theta. That's what we just did here. And I can give you the hint, cosine is negative in what quadrant? Cosine is negative in quadrant. Quadrant what?
2.
2. So the triangle that you draw has to look something like this. Quadrant 2, this triangle. And you have to use a SOHCAHTOA to do it. Try to do 28. This is tough. I didn't say it's easy. Anyone? Cosine theta is 5, negative 5 over 6. And anyone know cosine is what? Which one?
The adjacent over hypotenuse. So let's see.
Hypotenuse is always positive, so 6. That means the adjacent should be what?
The adjacent should be negative 5.
Negative 5, yeah. Go ahead and find what is your opposite is. You have to use the Pythagorean theorem to find it.
I got B is equal to the square root of 11.
Square root
Yep,
of
me
11.
too.
It's like a Pythagorean. You should know how to do that. So now you need to find what is secant theta. Do you know cosine is adjacent over hypotenuse? Then secant is what over what?
Opposite over 11
Secant.
over
Secant. It will be what? Negative 6 over 5. So that is your answer in this case, which is hypotenuse over adjacent. You with me here?
Yeah.
And what happens if I change this secant to become tangent? So what is tangent theta in this case? It's the same thing, right? You did everything the same. Now you just need to look at this triangle to figure out your tangent, which is what?
Square root of 11 over -5.
Yep, that's it. Okay. So what happens here is this only happens when these two are not. Last time we do sine and arcsine and so on, but this is a different one. So this is like this. So you have to draw a right triangle. And so for this question, which is like 27, 28, 29, they all look something like this. But if you look at question number 30 and 31, they are different, sine and arctan and cotangent and arctan. But what happened here is they're no longer using numbers, they use variables. Do you see that?
Mm-hmm.
So the first three here that we did, they're all numbers. They're all in the number form. This, they use variables. So when you have a variable case, then you just treat it as variables. So in this case, like question 30, when you have a sine of an arctangent of x. So the same thing happens. You have to let this become theta, and then tangent theta is equals to x over 1. So what we're going to do here is we're going to treat this as everything is in a positive. So your triangle will look something like this. So this is theta. And tangent is opposite over adjacent, right? So this is x and this is 1. So how do you figure out your hypotenuse? Is a squared plus b squared, and then you take the square root. Square of this plus square of that, and then square root. So now what you do here is this is going to be sine theta. And sine is what over what?
Opposite over hypotenuse.
And what is opposite in this case?
X.
Hypotenuse.
X square root of x squared plus 1.
There you go. And this is your answer for this case. So what is the difference between 30 and 31 with 29 and 28 that you just did just now is this one is going to be all in terms of x. But for 29 and 27 that you did just now is all numbers like 5, 6, and 5, 8 negative or something else. But this is all going to be in terms of x in this case. So this is how we figure out this. This is 30, 31 is a calculus type questions. You will see this a lot in Cal 1 when you do differentiation. You guys all right here with this?
Yep.
Yep.
Okay. So mostly, again, this chapter 6.6, we're still gonna use the right triangle. We still use your SOHCAHTOA to do this. Okay. And this is only done when these two are different. Okay. If they are the same, you can cancel it. Okay. So if this is sine and this is sine inverse, you can cancel it. Then your answer is just x. Okay. But if they are different, you have to do this way. Questions so far? Don't concentrate too much on the graph. I'm not going to give you the graphing piece. Same thing happens with some word problems. It's just that they want you to write this in terms of like question number 34. They give you that a boat pulled by the means of winch located on the dock 5 feet above the deck on the boat. Let theta be the angle of elevation for the boat and s be the length of the road. This is the s. So my question is, which one should we use for 5 and s based on the theta? Tangent, sine, or cosine based on your SOHCAHTOA?
Sine.
Sine.
So it'd be sine theta equals to what?
Sine theta is equal to 5 over s.
5 over s. But this question wants you to write in terms of theta. So what do I do with this sign is I move it over there. And do you know what happens when I move it over there?
be theta is equal to sine inverse 5 over s.
And yep, you have to put parentheses around it. Otherwise, they mark you wrong. And this S looks like a small letter S. So don't put a capital S because they will mark you wrong. So this is how we do question A. And then B, you just put S to become 30. And then S become 15 here. You substitute 30 and 15. And then you find the sign of it and you get your answer in your calculator. You guys all right here?
Yep.
So the word problems that we did here, they are all the same. So that's why you have to figure out which one. This one you have to use tangent because it's using opposite and opposite and adjacent. This one also, it looks like you're going to use tangent because you use opposite and adjacent. So you just need to figure out, I didn't even read the question. So you just need to figure out by looking at the picture, which one you have to use. Questions with this six here?
Nope.
That's fairly straightforward, just needs practice.
Practice, yep. Especially the one that we went through just now, those are the difficult one, the one with the sign, the inverse sign, and which one is undefined. Those are the one that is going to be a bit more tricky. So next thing we're going to talk about is chapter 7. So we're going to start chapter 7. So chapter 7 is where we were doing what we call as identities, trigonometric identities. So chapter 7 is what we call as a killing chapter, means that a lot of people will just roll their eyes and just like, what's going on? So this is the first thing I need to introduce to you guys is the fundamental trigonometric identities. So these are what we call as the reciprocal identities, which you guys already know. Sine is a reciprocal of cosecant, vice versa. Cosine with secant, tangent, and cotangent. So this is called the reciprocal identities. This is the quotient identities. Quotient means division. Tangent can write down in terms of sine over cosine. Cotangent is cosine, switch around, cosine over sine. So quotient identity is only used for tangent and cotangent to write sine and cosine. And then it has a Pythagorean identity. Pythagorean identity looks like a squared plus b squared equals to c squared, which is sine squared plus cosine squared equals to 1. And then this Pythagorean identity comes with the other two. So how do they got the other two identity here is they just use, they divide. So what happened is that, so when you have sine squared plus cosine squared equals to 1. So if you divide everything here by cosine squared, you will get a new Pythagorean identity. Now we know sine over cosine is tangent. See, sine over cosine. So this is a tangent square plus cosine square is 1. And then 1 over cosine is secant square. So that's why you will get 1 plus tangent square equals to secant square, this identity. And if you still use back the same Pythagorean identity that we have here, but you divide this instead of cosine, you divide this with sine, what do you get? Sine over sine is 1. What is cosine over sine? Cosine over sine is a
Cotangent.
cotangent square, because it's a square over there. And what is 1 over sine? 1 over sine is a cosecant square. So now you will get the other Pythagorean identity, which is this one. So that's the reason why that if for Pythagorean identity, I just need to know 1. The other 2, I can derive it very easily by divide by cosine and divide by sine. Okay. So that is what we call as a Pythagorean identity. Next is called the co-function identity. Co-function identity is used when you have 90 degrees minus. I just want to point out to you guys that sine and cosine has a co-function identity. A co-function means that if you add the 2 angles up, there should be 90 degrees. So that means sine 60 degree is the same thing as cosine 30 degrees, which in this case is root 3/2. And if you figure out what is sine 12 degrees, sine 12 degree is the same thing as cosine what? So the addition of this has to be 90 degrees. 78. So these are the same. So if you take out your calculator and press sine 12 and you find cos 78, the numbers are exactly the same. Tangent and cotangent share the same thing. So cotangent of 451 degrees is the same thing as tangent 39 degrees. Same thing with secant and cosecant. So this is what we call as a co-function identity, means that if you take this sine and this cosine angles and add them up and you get 90 degrees or pi over 2 in radian, they have exact the same value. You guys all right here with the co-function? And the last one is an even odd identity. This even odd identity is taking care of the negative value. So if you want to find what is sine negative 60 degrees, so we can use this even odd identity. I just want to point out to you that sine, cosine, tangent, and cotangent are odd. What I mean by odd is if you have a negative angles, this negative angle, you can bring it up, okay? But for cosine and secant, they are even identity. And what's even identity is if you have a negative angle, you don't bring the negative up, it's still gonna be positive. So what I'm talking about here is if you have sine negative 60, this negative, you can bring it up. So this is actually is negative sine 60 degrees, which is negative root 3 over 2. But what happens when you have a cosine negative 30 degrees? Because cosine is an even function, this negative will disappear. So you do not need to pull it out. So what you have is just a cosine 30 degrees, which is in this case is root 3 over 2. So this even and odd functions that identities that we have here is used a lot when your angle is negative. So cosine and secant, the negative will become positive. The rest of it, the negative will be pulling up front. So that is the meaning of the even and odd identity that we have here. You got okay here? These are all the identities that we have. This is just the fundamental, means this is the basic trigonometric identity. So when you go on to chapter 7.4 and 7.5, there are more identities coming up. This is just like basic. So when you do chapter 7.1 homework, you have to use the identities really a lot in this chapter 7. So the basic one is something that, so the first few questions are very straightforward, like they use the identity here. So cos over sine is what? Anyone know cos over sine? What kind of identity is cos divided by sine?
The quotient identity.
Which is what? What's cos over sine is?
Cotangent.
Cotangent. So if you just put cotangent, they will mark you wrong. So it's cotangent u. Okay. So mostly the first few of these, they're all based on your identity. So make sure you guys go to the identity and look at it. Oh, by the way, I forgot to mention that. This is also very important. The identity that you see here is not fixed. What do you mean by it's not fixed? You can do some algebra work on it. For example, the Pythagorean identity that you have, tangent square plus 1 equals to secant square, I can move the 1 over. So I can write this as tangent square equals to secant square minus 1. This is still a Pythagorean identity. Same thing happens to sine square plus cosine square equals to 1. I can move the cosine square over there or sine square. So your sine square is 1 minus cosine square. So this is still a Pythagorean identity. So what I want to tell you here is all this identity that you have here is not fixed. That means you can move it. So for example, here is when you see the here, you got sine u equals to 1 over cosecant u. So if I multiply cosecant u here, so cosecant u times sine u is 1. This is also a reciprocal identity. You guys know what I'm trying to say here? That means you can multiply, you can move things around, you can, like algebra, you can multiply this to that side, you can move the tangent to that side, you can move the cosecant, you can move the one, you can move things around here. This one you cannot distribute. I'm going to point out to you here, do not distribute your cosine or your cotangent inside here. This is wrong, okay? So the cofunction and the even odds, there's nothing much you can do, but the first three of this, you can actually move it around to figure out what's going on. So for example, here is this question 7. So for question number 7 is telling us that cosecant theta is 13 over 5 and tangent theta is 5 over 12. Can you guys figure out what is sine theta is? So cosecant theta is already given to us, 13 over 5. And tangent theta is already given to us, 5 over 12. This is already freebies. So can someone tell me what is sine theta in this case? This is not difficult. Sine theta is a reciprocal of which one?
Of a cosecant?
And we know cosecant is
5
13
over 13.
Mm-hmm. And can you tell me what's the reciprocal for tangent?
Cotan, so 12 over 5.
So these are pretty straightforward type. So we got the sine, which is 5 over 13, and we got the cotangent, which is 12 over 5. So my question to you now is, how do you figure out cosine theta?
Well, you already know from tan theta that the adjacent angle is 12, so that would just be the adjacent over the hypotenuse. So that would be...
So you can use that. So this is a tangent theta. So this is 5 over 12. So that means your hypotenuse should be 5, 12, and anyone know the magic triplets?
5, 12, 13 triangle.
13, yep, 5, 12, 13 triangles. So what is cosecant theta in this case?
Cosecant theta? You mean secant theta or?
Cosine theta, sorry.
That'd be 12 over 13.
And the secant?
13 over 12.
Okay, so this one you guys know. It's not too bad, right?
Mm-hmm.
About question 8. So if I give you 2, it's easy, right? If I give you 2 angles like that, it's easy. But question 8, they only give you 1. So this is mostly what you get in my finals is 1. So the first thing you need to figure out when you do question 8 is what quadrant is this belongs to. And then you have to draw me the right triangles, because if you give me the wrong triangle, it's going to be wrong. So secant is negative, and tangent is also what? Well, less than 0. Less than 0, is that positive or negative? Tangent is also negative, less than 0. So what quadrant if secant and tangent are both negative? And if you give me the wrong quadrant, you got a lot of wrong answers. Anyone? What quadrant? Secant. What quadrant makes secants negative? Quadrant what?
Quadrant 2?
And quadrant 3, right?
Mm-hmm.
And for tangent negative is quadrant what? 2 and quadrant 4. So which one is common between those two?
Quadrant 2.
Quadrant 2. And don't forget, in order for you to draw the triangle, it looks like a ribbon. So that means that your triangle is no longer quadrant 1. This one is a quadrant 2. So it looks something like this. That means that this number has to be what? Negative. Your y value and your hypotenuse will be positive. And it's given to us, secant x is negative 9/5. So what is the opposite of secant? Cosine x, which is negative 5/9. So can you fill up this triangle, what it looks like? Where's the negative 5 goes to and where's the 9 goes to?
Negative 5 to the adjacent, 9 to the hypotenuse.
So you have to figure out your opposite.
Be 81 minus 25.
So where's 81 minus 25?
56. So
Square of 56, but you have to break it down. So if you give me 56 in your finals, you will take a point off. What can you break down 56 with? Is it divided by 4? Yep. So it's 2√14. So this will be 2√14 here. So if you give me root 56, everything you did here will be wrong. So that's why you have to use 2√14. Then after that, I think you know how to do your SOHCAHTOA with sine, tangent, and so on, right?
yeah.
So this is pretty straightforward. The most important part about this kind of question is to figure out what quadrant it belongs to. Because if you give me the wrong quadrant, your sign is all going to be messed up. Because in quadrant 2, which one is positive? Sine is positive in quadrant 2, and which one is positive in quadrant 2 besides sine?
Cosecant.
Yep. So when you do your task, once you finish doing all this work, just take a 10 seconds check. You know this is quadrant 2. So sine and cosecant will be positive. The rest of this answer should be negative. You with me? And if you don't get this, your triangle is everything is wrong. That means you're in the wrong quadrant. Questions? Okay. Some of these are pretty much mix and match. So, so for example, we have is question like number 12. So can someone tell me what is secant x times with cosine x is? This is where you start to prove identity in the next section. Yep, 7.2 is where you start to prove identity. That is difficult. Can you change secant in cosine? So secant x is what? This is not that tough. This is where you start to prove your identity. Secant x is 1 over cosine x, right?
Yes.
And then you still have a cosine x over here. And then what happens to cosine x and cosine x?
Cancels.
So you just get 1. And that's your answer. So this is 7.1, where they want you to simplify this. But in 7.2, you will start to prove your identity. And the identity they want you to prove is they want you to prove secant x times cosine x equals to 1. You have to prove this. And this is how you prove it. How about 13? Cosine squared pi over 2 minus x divided by cosine x. This is, see how many of you will get it. Anyone?
So to reiterate, you can't distribute cosine squared within.
You are correct. And there's no foiling here because the square is not here. The square is in here. I told you this is tough.
Would that be the denominator cosine x would cancel with one of the cosines squared to cancel the bottom?
Can't cancel because they're not the same angle. If they are cosine square x and cosine x, they're same angle, yes, then you can cancel.
Can you go back to the identities then quick?
So make sure you got this identity with you.
So does it equal sine u then?
So so the cosine square is the same thing as sine square. So this is the same as the cofunction. So cosine pi over 2 minus u is sine u. So if I put a square here, it will be a square here. So in this case, this top one is the same as sine square x over by cosine x. What else we can do?
That would be tan u, wouldn't it?
Sine squared can break into 2. So it'd be sine x times sine x, right?
Yeah.
And this is all over by cosine x. So what happens when you take one of this? Sine x over cosine x, what is that?
That would be tan x, correct?
This would be tan x, and we still have what left?
Times sine x.
So tan x sine x. So your answer in this case would be tangent x sine x. Tough?
You just got to kind of look at the.
Yes, you are correct.
It won't
This
be
is, and I told you this is the basic one. So when you go on to the future, you got like 20 more of this.
Oh.
We got around like 30 to 40 trigonometric identity, and this is called the basic one. If you look at 7.4, there are you will have a couple more. You got a few more over there. So this is 7.4 identities. And then if you look at 7.5, which you will cry when you look at it, the identities for 7.5 is 1 page long, which I show it to you in my so those are the identity for 7.4 just now, and then I'll show you to you the 7.5 identity. It's in my notes, and you will not like it. So that's the reason why that you need to know the basic one, and then 7.4, 7.5 identity that you see there, you will need that when you go to calculus, because in calculus you will be using all these identities like crazy. That's the reason why that these are really, really important in calculus. 7.2, 7.5. Let me take a look at the identities for 7.5. So please also watch the detailed notes. I don't know if you guys did this. So this is the 7.4 that I showed to you just now. And then 7.5, you got double angle formulas, power reducing, half angle, product to sum to product. These are all the identities for 7.5. So each one have at least 3 of them. And then you got the 7.4, the one that I showed to you, the sign, addition, and subtraction. And then you got the basic one that I just showed you just now on 7.1. Tough? And you begin to do a lot. I'm not gonna scare you, but I just want to tell you that this is something that you guys need to do it your own. Even if I'm teaching this face-to-face, I cannot teach you this because you have to think outside the box. I cannot teach you how to think outside the box. The only thing I can tell you is I can show it to you how it looks like. Like here, I can tell the answer already, but so you have to write something out like this. So in the test, I will say, I want you to prove this is equals to 10x sine x, and this is what you need to write. So when you do, this is almost 7.2. You're gonna do this, tough. And let's do one more before we close this, is 14. 3 secant square x minus 3 over by secant x minus 1. This is even worse, not even a multiple choice. So you have to type in your answer here. I can give you the answer, but you have to prove it. So I want you to prove this. I know the answer. Yes, I do know it. The answer in this case is 3 secant x plus 3. I'm going to erase that. So I want you to know how to get from here to here. That's your answer. Yes, that is your answer. So in the test, I will want you to prove this. 3 secant x plus 3. Anyone? I told you. I can show you the identity back. That's your identity back. Anyone? Last, before I close this. This is what you do in 7.2. And you will get this kind of questions in your finals. And I know it's hard. So I can tell you that this is just put 3x plus 1. I can factor the 3. So what do I do first is I factor the 3 out. Top. So what I get here is secant square x minus 1. Denote the same thing. Now you cannot cancel these two. The reason why you cannot cancel these two is because this one has square. But this you can factor it because this is the same thing as a squared minus b squared. You know what's a factor for a squared minus b squared?
C squared?
No, not Pythagorean. Factor. What is x squared minus 9 when you factor it?
Plus 3 minus 3.
So it's x minus 3, x minus 3, plus 3, right? So this is the same thing as a squared minus b squared. So you still get 3. What you get here is secant x minus 1 and secant x plus 1. Because it's like, or you just say x minus 3 and x plus 3. This is a and b. This is all over secant x minus 1. Now this will cancel out. And that's why you end up with this. 3 times secant x plus 1. Welcome to chapter 7, killing chapter. And a lot of students will be crying during my finals. I can tell you that this proof that we just did is level 3. You haven't seen the level 5 or level 6 yet. Those are even difficult proof. Those I cannot even see. I have to work. This I can see level 1, 2. The first one that we did just now, the sign, the easy one, that's a level 1, level 2. That's an easy. These are level 3. I still managed to see the answer, what to do. But once you reach level 5 and 6, forget about it. You have to really work really hard for it. And we have some of those. So make sure you guys, when you guys do this, this is all in 7.2, which is what we did. The only thing about 7.2 when you do proving, it's not the same thing as solving. So a lot of students, when they try to prove this, what they do is, oh, I can just multiply this to here, secant x minus 1, and then I just FOIL this whole thing out, and I will get back this one. You get a big fat 0 in the test if you do that. Because you are not proving, you are solving. Because once you multiply the secant x minus 1 to that side, you are solving an equation, not proving an identity. So that's why you get a big 0 if you do that. You with me?
Yep.
So yep, just again, chapter 7 is killing chapter. So I would recommend you guys, if you have any questions, you can come and talk to me. Please refer back to my notes, the instructor notes that you guys have in D2L. I don't know how many of you watched, look at these notes, but I will really suggest you to look at these notes. This is the same thing we just go over. They will go over like things like we just did over here, like, factoring, like remember this like factoring, the a squared minus b, a squared minus b squared. So you will get that kind, so at least you know what you're expecting. So I would recommend you guys to go over the, especially go over the 7-1 notes and 7-2 notes. And that will be your homework for this coming weekend. I will look for videos to do this, but I can tell you already the whole chapter 7 is most, especially 7.2, is mostly you have to think outside the box. So I cannot really help you with that. So that's why I can tell you that. So I'm going to stop sharing here. Anyone have any questions for me? So chapter 7 is a killing chapter, so you might need to take some time here. So if you don't have any questions, you may go.